Hello friends, welcome to this video on areas of parallelograms and triangles. Today, we will discuss about parallelograms on the same base and between the same parallel lines. So let's start with an activity. Take this type of sheet where the points are at equal distance. We call this the isometric sheet. On this, we will create the parallelogram PQRS in this way. Now, take a point T on the side PQ above S. Now, connect ST. Here, we will get a triangle PTS. We can see that triangle PTS and quadrilateral TQRS together form the parallelogram PQRS. Let's cut the triangle from here and connect it with the side QR of the quadrilateral. Let's assume the name of the quadrilateral thus formed is TURS. Can you tell what type of a quadrilateral is the quadrilateral TURS? We can see that its sides are equal and parallel. This is also a parallelogram. Friends, if we compare parallelogram TURS with parallelogram PQRS, will these two have any similarities? Pause the video and think about it. Friends, here we have only cut the triangle PTS from one side and added it to the other side without making any other changes. We can see that both the parallelograms are made up of triangle PTS and quadrilateral TQRS combined together. Therefore, the area of these two parallelograms is equal. Friends, here parallelograms PQRS and TURS are located on the same base RS and between the same parallel lines PU and RS. And their area is also same. This is a theorem that states area of parallelograms lying on the same base and between the same parallel lines is equal. Let us see the mathematical proof for this. Let us consider the quadrilaterals that we used in the activity. We have two parallelograms, quadrilateral PQRS and quadrilateral TURS. These two parallelograms lie on the same base RS and between the same parallel lines PU and RS. We have to prove that their areas are equal, where we represent the area in this way. Here, AR represents the area. Looking at the figure, we can say that the parallelogram PQRS is made up of triangle PTS and quadrilateral TQRS combined together. That is, quadrilateral PQRS is equal to triangle PTS plus quadrilateral TQRS. Similarly, parallelogram TURS is made up of triangle QUR and quadrilateral TQRS combined together. So, quadrilateral TURS is equal to triangle QUR plus quadrilateral TQRS. Let us call it equation 2. In equations 1 and 2, we can see that quadrilateral TQRS is a common quadrilateral. To prove that the area of both these quadrilaterals is equal, that is, quadrilateral PQRS is equal to quadrilateral TURS. We will have to prove that the areas of triangle PTS and triangle QUR are equal. And if we look at triangle PTS and triangle QUR, then we will find that
angle TPS is equal to angle UQR because PS is parallel to QR and PU is a transversal, because of which these angles are making a pair of corresponding angles. Similarly, angle PTS is equal to angle QUR because TS is parallel to UR and PU is a transversal, because of which these angles are making a pair of corresponding angles.
Since two angles of this triangle are equal to two angles of the other triangle, therefore, the third angle will also be equal because we know that the sum of the three internal angles of a triangle is 180 degrees. Therefore, angle PST will be equal to angle QRU according to the angle sum property of the triangle, and side PS is equal to side QR because the opposite sides of the parallelogram PQRS are equal.
Therefore, both these triangles will be congruent by the angle side angle congruence rule.
Therefore, triangle PTS is congruent to triangle QUR and the area of congruent triangles is equal. Therefore, triangle PTS is equal to triangle QUR. Now in equation 1, if we place triangle QUR instead of triangle PTS, then the equation will become, and by joining the two areas on the right, we will get the area of TURS. Therefore, area of PQRS is equal to area of TURS. And thus, we have also proved mathematically that the areas of parallelograms lying on the same base and between the same parallel lines are equal. Friends, we saw that areas of parallelograms located on the same base and between the same parallel lines are equal. Is the opposite also true? That is, will parallelograms with equal base and equal area be located between the same parallel lines? You must consider this. We will discuss it in the next video. Friends, with this, let's end this session. In the next video, we will solve the inverse of the theorem as well as some questions based on it. See you in the next video. Thank you.